Okay, well, let's take a look at question 5 in sample exam 3. There's a dimensional analysis component to this question as well as thermochemistry. It says that in a typical car engine reaction, you're basically burning gasoline, so combustion is gasoline with oxygen to produce energy. And then the enthalpy of this combustion is given. And so the question is, if the car consumes some amount of energy for every mile it travels, how many gallons of gasoline do you need for a trip from Los Angeles to Las Vegas, which has certain distance? And a couple of additional pieces of information is given here, which is 1 gallon conversion to liter, and then the density is also given. Okay, let's kind of work backwards here because we want to know the volume of gas, right, in gallons that we need. They tell us density in this case, and they also tell us the energy that's needed, and they tell us the distance. So we want to know the volume of the gas in gallons. And so what we need to think about is how much energy is 1 gallon providing. So that's one of the things that we want to know. And then of course the other question is we want to know what is the total energy needed for the trip. So the top one would be some units of kilojoules per gallon. And then this would just be kilojoules per trip. You can think about it, but there's only one trip, so it's kilojoules. So if you have kilojoules and kilojoules per gallon, you can see how both of these quantities can then be converted to solve for just the gallon. That means to divide one by the other one. And we'll do that, but we're going to need to figure out these quantities first. So how do we figure out how much energy per gallon of C8H18? Now, that requires several steps of conversion. They actually give us information about how much energy you get when you burn gasoline. It's right here in this value, which is the delta H, right? We just have to write out the actual reaction to figure out whether that delta H is something we can use or not. So let's write out the reaction itself. C8H18 plus oxygen. And remember that these type of combustion reaction always produces these two products. So if we try to balance this out, we're going to get 8 here, 9, and then this would be 25 over 2. And we can then straighten this out, getting whole numbers for everybody by writing this equation. Now, so this is the reaction whose enthalpy is given in the question, which is negative 10,992 kilojoules. And remember that they don't really write the unit at the bottom here, but remember this stands for per mole of reaction, right, or per mole of the balance equation. Now, what we're interested in specifically is the amount that you get from the gasoline itself. So we want to know how much you get from here. So that means we need to convert the delta H from per mole of reaction to per mole of C8H18. So let's do that. This is per mole of reaction, and we can say that in 1 mole of reaction, there is 2 moles of C8H18 based on this equation. So that means you get that much energy per mole of C8H18. Now, the goal in the end is to get how much energy from each gallon of C8H18. Now, gallon is a volume unit, so that means I have to take my number of moles and convert it eventually to some kilojoules per gallon. And you can see that given the information I have in the question, I have density, so that means that I probably have to take this through mass first, and then eventually to volume, and then convert the volume unit. So that's what I'm going to do. I'm going to try to get the energy per gallon of C8H18, and this would require a few conversion steps. So I'm going to start with my 5496 kilojoules per mole, and then I can convert this to mass by using my molar mass, 114 grams in 1 mole. When I do that, now I have it per gram of C8H18. So I need to do a conversion between mass to volume, and that of course is density. So 0.703 grams per milliliter of C8H18. Now I have it per milliliter, but I want it per gallon. There's a conversion between gallon and liter, so I need to do a conversion from milliliter to liter, which is just 1 to 1000. And then I need to do one more conversion, which is liter and gallon. And that's given in the question to be 3.785. So when I multiply across, you can see what I end up having at the very end is a unit of kilojoules per gallon, right? And so that ends up being a big number, 128,279.82 kilojoules per gallon of C8H18. I'm not rounding any of this number yet because I'm not done with my calculation. So that's one of the quantities I need. It's this one right here. Now I need to find the second quantity, which is how much energy I need for the trip. To do that, I was told that the car consumes some energy per mile, and then the trip itself is 277 miles long. So then I can calculate energy energy needed for a trip, and that's just going to be the amount of energy needed by the car, which is this much per mile times 277 miles, and that gives me about 2 million kilojoules of energy. So now that I have these two numbers right here, kilojoules per gallon, kilojoules of energy needed, I can use dimensional analysis to find out volume of gas needed in gallons. So that would just be taking the gas I need, which is this, times the inverse of the amount of energy per gallon, which is 128,279.82. And the kilojoules cancel, giving me just answer in gallons, which ends up being 16.24 gallon. And so going back to the original question, closest answer would be 16 gallons. Okay.